All right, so today we're going to talk about cloud networking and traditional networking. And a couple things that I really want to kind of keep in the back of everyone's mind is not just networking at the edge of the cloud, but also networking within the cloud as well. And there's a couple different dynamics to that we'll talk more about. So when we talk about bridging the gap between traditional networking and cloud networking, what we're really talking about is there's a lot of similarities to building an actual bridge. And in the previous slide here, I kind of had like half a bridge there, as you can see, as it's under construction, and which is kind of a reference to the bottom there about what do you call half a bridge? It's just a dock. But if you think about building a bridge, it's really, there's a lot of engineering that really goes into play to really make it happen. We got to figure out what obstacles we got to go over. Are we going over water? Do we need to pour the concrete into water? There's a lot of requirements gathering. How far does the bridge need to go? What's going to go over the bridge? So all of these things have to be taken into account, and it's very much like when we're building networks. So if we look at public cloud, it's no longer it's coming. Like it's here. So for those of you that aren't involved in the cloud yet, just wait, it'll become a thing. Does anybody not have any cloud service that they consume in some manner, personal or professional? I was gonna say I'd love to talk to you and find out what kind of rock you're living under. But cloud's here, it's a thing. Just the numbers here, even when I was building the slide, were just tremendous. And so if you think about just the overall growth, it's continuously growing 20+% year over year. 500 million workloads are in the cloud. I'd be very fascinating to know how many workloads are on-prem versus in the cloud, but nevertheless, it's very significant. The other thing that's also growing is multi-cloud. 92% of enterprises have said that they're in one or more cloud of some kind. So the multi-cloud stuff is ramping up as well. Overall spend, this year we're projected to end at 500 billion, and then next year it's supposed to go up to 600 billion. So just huge numbers. And one of the reasons for all this growth, when we really think about it, is there's a lot of emerging markets, but one of the big ones is AI. So as more and more organizations try and figure out how can we make our applications more AI enabled, AI is going to continue to drive that and really double and triple in a lot of cases. If we look at the market share perspective, there's really three main players in the market. There's with AWS, Microsoft Azure, and then Google Cloud. There's some honorable mentions there with Oracle and Alibaba as well that are definitely worth looking at as well. But for today, we're just going to focus on those three. So now we know public cloud's a thing, it's here, but why did it get here? And if we look at kind of like what are some of the drivers that drove people to the cloud, agility and elasticity, that's a huge thing. Being able to just swipe a card, spin up a workload, it's just very easy you don't have to worry about the compute that's actually behind it. Yeah, all you have to worry about is just, can I pay my bill when it comes due in 30 days is really the biggest thing. But there's also, for my other fellow vendors out there, I sympathize with you, lead times, they suck. It's hard to deal with. You order gear and you're being told that it's not gonna be there in 2 weeks anymore. Like, there's nothing we can do about it, unfortunately. I wish we could, but it is what it is. In the cloud, you don't have to worry about that. Again, supply chain is not an issue. It's an issue in a different sense for them, but really that's really masked by the actual CSP. Collaboration. This is one of the reasons that also cloud became a thing was it's very easy to collaborate on a platform that's universally available to everyone. Business continuity and disaster. This is probably get tomatoes thrown at me right now, but business continuity and disaster is also an area where you can, there's a right way and a wrong way to do it, of course. But there are lots of options available from a DR standpoint, and at a higher up executive type level, it may seem like a good idea because there's global reach as far as what's available. Simplicity, really, we kind of hit on all of that with all the above already. And then cost effectiveness, that's another one that's up for great debate. If you're just looking for maybe it's a small application, 1 or 2 servers that you need, do you really need to spin up an entire server stack and an entire rack of equipment just for 1 or 2 servers? It may be a little excessive. Now, when we start scaling that environment out, then it may be up for debate a little bit more about whether or not what's the most cost-effective way to do it. But then my last and most favorite one, and the reason for the inspiration for the image is it seemed like the hip thing to do. So if you get really bored and you want to read some 10K filings from some of the big organizations out there, unless they're like a data center provider or colo provider, you'll find few and far between board minutes where they say, hey, we're going to invest in the data centers and we're going to build more of them. Like, no one's saying that, unfortunately. What they're really saying is we not only want to know about the cloud strategy, we want to know what the cloud execution really is now. So just a few things to think about as far as why we got there. So when we talk about really public cloud networking, and really one of the things that I really want everyone to think about again is not just what's at the edge, but also what's within the cloud. We really we want to be part of those conversations. So we need to provide a cloud-like experience to our actual end users. So just something to keep in the back of your head. One of the kind of ways to provide that cloud-like experience is you got to kind of like back to going full circle back to building a bridge. You got to know what your requirements are. And so part of that is to know what your requirements are, you got to have a seat at the table. And to get that seat at that table, they're unfortunately not just going to say, hey, come in, we want to tell you everything about what our cloud strategy is and what we're going to be doing in the cloud. You have to earn some credibility with them because unfortunately, the network that you built on-prem gets you some credibility, but it's not going to get you a full-on seat at the table. To actually get that seat at the table, you have to be able to speak the language. And we'll kind of double click on this to talk a little bit more about some of the nomenclatures and stuff that goes with cloud networking. But then you also have to be part of the pipeline. I was kind of laughing earlier because I was like, we should have a drinking game for every time someone says pipeline today. But it is true. You've got to be part of the pipeline, and you've got to enable that pipeline. And you also have to be able to build and enable that pipeline. And what part of that is saying yes, instead of just saying like, no, this is my network, you can't do that on my network. You have to be willing to say yes and open up and figure out a way to enable what the end user is actually trying to do. Last, you have to fail fast. That's a common phrase in the DevOps space, but I'll caveat that with you still need to succeed. Because guess what? If you just keep failing, what's going to happen? They're just going to say, forget the on-prem, we're going 100% to the cloud, and we're done with it. All right, so now we got a seat at the table. How do we actually keep it? You got to be part of that pipeline. So you got to provide APIs into your network. That's what the cloud's doing. They're giving all their developers a way to actually have an API into their network. So you can go into whatever cloud and build whatever virtual networking stack you really need to do. So be part of that pipeline. Basically, you are the CSP for that on-prem world. You also got to be part of the team. So one thing that has been very encouraging that I've seen is I've seen more and more cloud network engineers instead of just network engineers. So we got to have that seat at that table and really be ingrained into that cloud team. Last, we got to be innovative. The CSPs are innovating every second. As I was making this slide deck, I was kind of thinking to myself, I was like, man, I bet half this slide deck is going to be obsolete by the time I actually get to present it, because AWS is going to launch 10 new services by the time I started and when I'm done. So stay innovative. Don't be a dinosaur. All right, so let's talk more about really dissecting a cloud service provider. CSP is really the common industry accepted term for the cloud, the CSPs. So if we look at the diagram that we got here, every CSP has a virtual networking stack. They also have a storage stack, databases, platforms as a service, serverless compute, containers, and then finally your compute, your virtual machines. The fun thing is every CSP has different names for it. So to get that seat at that table, you have to at least have some knowledge level of what everyone's talking about as far as when they're saying, hey, this S3 bucket needs to communicate with this other service over here in this other VPC. And so so this is where we'll actually break down a little bit more, more like a 100 level overview of the different services that the different clouds have. So with AWS, their virtual networking stack, more or less, or one of the components is called a VPC, a virtual private cloud. The storage, one of their offerings that they have is S3 buckets, RDS for the database, Beanstalk for the platform as a service, Lambda for the serverless compute, EKS is their Kubernetes service, EC2 is the compute. So EC2, a lot of times you'll hear EC2, S3, just know that those are AWS terms. So if we flip over to Azure, instead of VPCs, they call it a VNet. Their storage, one of their storage offerings is a blob storage, Azure SQL, app service for the platform as a service, Azure Functions is their serverless compute, AKS is their Kubernetes offering, and then they just call their compute virtual machines, VMs. Google Cloud Platform, similar to AWS, goes with VPC, and we'll talk more about some of the differences with each individual one in a second here. So their networking stack is a VPC. They also have cloud storage for their storage offerings, Cloud SQL. One thing you'll kind of notice is that they like saying just cloud, whatever it is. So we've got App Engine, then Cloud Functions for the serverless compute, GKE for the Kubernetes, then Compute Engine or virtual instances is really what they call their compute on the Google side. All right, so AWS on the networking side. So AWS, again, one of the biggest player in the cloud space right now. They have a lot of different options from a networking standpoint. But if we kind of take a step back from the networking and just think about how exactly AWS is structured, at the highest level we have different accounts. And so as an organization, you may have different accounts that all have all these components underneath it spread out amongst them. There can be some ways to integrate things together, but just when you hear accounts, just know that that's really kind of the top level within AWS. We also have different regions within AWS, so US East 1, US West 2 or West 1. These are all different regions. These kind of represent a physical area where the data centers actually are. If we look at availability zones, these are actual physical data centers. So you may have different AZs within a given region. Virtual private clouds, VPCs, think of these as more of like on the on-prem side, we'd call it more of like a VRF essentially. Under the VPCs, we also have subnets. We got public subnets, private subnets. With public subnets, those are what we usually use to get out to the internet, which ties into the next one here with IGW. If you have a public subnet, you can access an IGW directly to get out to the internet. If you're on the private side, then you just use a NAT gateway to get out, and that would handle all the network translation. We also have network ACLs. The network ACLs are more of a stateless ACL, where the security groups are a stateful ACL. The network ACLs are applied more at a VPC level, where the security groups are more at like the actual application. So like S3 bucket or an EC2 instance. From a networking standpoint, and one of the bullets I keep forgetting to add on to the slide is transit gateway. Transit gateway is what they actually use to move traffic from one VPC to another VPC. But one of the things that really ties into that is both the Cloud WAN and Direct Connect. Cloud WAN is kind of their offering to be able to enable things like SD-WAN connectivity and allow you to use their backbone and whatnot. Direct Connect is where AWS actually gives you a port off of their network, so that way you actually have dedicated access back to the AWS network. On the Azure side, a lot of similarities again. At the highest level, instead of accounts, we call them subscriptions. We also have resource groups, which is really our container for everything underneath that resource group. Inside that resource group, we have different VNets, which is their equivalent to like a VPC essentially. They also have a concept of NVAs, Network Virtual Appliances, which is really just a virtual VM that actually participates in some form of networking. So maybe it's a next-gen firewall or something, or a third-party router. We also have load balancers that confront those NVAs to help balance traffic within the network. But we also have user-defined routes, UDRs. So welcome back to static routes. Everyone missed them, right? UDRs is probably one of that's definitely one of the ones you want to keep an eye on, because it can also get very complex as your cloud environment grows. On the ACL side, they just have a general term for just network security groups, NSGs. And then they also have an offering kind of similar to the transit gateway in some respects, where to move traffic between different regions, different VNets, it's called Virtual WAN, vWAN, where it's basically a hub-spoke model, where we have different spokes for all the different workloads, and then we have a central hub where we can do central shared services. Like I said, they're always innovating on that side. So one of the innovations that they just launched back in September was the Azure Route Server. With Azure Route Server, it allows you to actually do BGP peering back into the Azure Fabric, so that way you can actually exchange routes within the cloud a little more effectively than what you could before. Then finally, ExpressRoute is really their service to actually offer you a port on their network, so that way you have that dedicated bandwidth and lower latency link back to the Azure network. On the Google Cloud Networking overview, we have different projects at the highest level. So again, you may have different projects for different groups within the organization. We also have virtual private clouds, so VPCs on the Google side. Big difference between the way that Google does networking versus some of the other CSPs is their VPCs are global by nature. And what that really means is you can have a single VPC that's stretched across the entire globe. So if you have, let's say you have 100 regions that are actually enabled on that VPC, you'll have 100 different subnets to represent all the different regions that you have within that VPC that can all freely talk within that VPC. So kind of a different take that they have on that. So the regions are what's really tying you back to the region, not the VPC. Went through the regions and the subnets, so down to the cloud routers is more their generic terminology for basically getting outside of that VPC. You hit a cloud router to actually get out of it, or to cross communication between different VPCs. The Network Connectivity Center is another relatively new offering that they have. NCC, where with NCC as it is currently, it's more for like connecting SD-WAN type technologies back to the cloud fabric. They have a longer vision of doing more things with NCC as well, so another thing to keep an eye on. Their offering to actually get a port on the Google Cloud is called Cloud Interconnect, and again, that's just a way to get some dedicated bandwidth and have good guaranteed capacity back to the Google Cloud. All right, so now we've got a good idea of some of the different terminologies and everything, and so that's more within the cloud. So like I said, I wanted to talk a little bit about actually what's happening in the cloud, because those are very relevant discussions that can have a direct effect to what's actually happening on the on-prem side, whether that's extending one VLAN out to the cloud from an L3 perspective or whatever. It's important to understand those concepts that are actually happening inside the cloud. If we look at connecting to the cloud, it's also a very, very relevant discussion. There's different options here, and by all means, none of these are exhaustive lists. There's lots of different ways to do it. VPN being one way, CSP connectivity, like we were just talking about, being another, and then bandwidth providers like Equinix, Megaport also have their own offerings as well. So VPN connectivity, it's fast, both in the actual time that it takes to actually turn it up. You don't need to call anybody up and say, hey, I need a VPN. You can just do it. Log into the dashboard, set it up. Also from speed-wise, you can scale it out using ECMP and stuff to actually get more bandwidth to the cloud. Obviously, VPN, it's encrypted. So you've got IPsec there, well-proven technology on that front. And then we also have different redundancy options where obviously it's very, when we're doing things from more of a software-ish type approach, it's very easy for us to spin up multiple VPNs for redundancy than say if we need a physical circuit from one region and another to another region. Just some key things to kind of take into account is where exactly are you going to have that VPN land? Are you going to land it in like a shared services, or are you just going to stitch it into its own VPC where the actual workload is? So these are all design topics to just kind of think about, keep in the back of your head. So on the CSP connectivity standpoint, there's obviously lowest latency because you're actually going to port off of their network. The other big thing with this too is high bandwidth. If you need 100 gigs to AWS, you can get 100 gigs. And if you need more, you can obviously add more connectivity from that because it is dedicated capacity. You're not going over a shared medium like the internet to actually get to the cloud. Another thing to kind of factor in though, it is region specific. So if you need some regional diversity, you'll need to be ordering multiple circuits to be able to achieve that. The other thing too is if encryption is interesting to you, or important I should say, there are some options out there with MACsec. Just bear in mind, if you do go down that path, you may need some specialized hardware to actually support the MACsec encryption. Bandwidth providers. So again, talking about like an Equinix or Megaport, and I'm sure there's a bunch of others. Deft, I think, has offerings as well. So really, they're incredibly cost effective for the most part, considering when you factor that in versus actually doing, say, dedicated connectivity. So when you look at, and what I mean by cost effective is if you don't need, let's say you get 100. Did I break it? Oh, good. Okay. I was like, I swear I didn't touch anything. So when we're talking about cost effectiveness, if you need, let's say you order a 100 gig pipe, but you really only need like 15. So you need more than 10, but less than 100. The CSP route may not really make sense. But going with a bandwidth provider that can give you more, maybe give you 15 gigs to AWS and 15 to Google and 15 to Azure, that may be a good route to go because you've got a little bit more flexibility with what they can actually give you. Also, quick turnaround time is obviously, if you're already in one of their facilities, it may be as simple as just a cross connect, or maybe you already have a connectivity to them and you just say, hey, I need a virtual circuit spun up to whoever the CSP is. From just geographic availability, they're everywhere, so very easy to get in touch with. Same concerns kind of on really both the VPN and the CSP route. You got to factor in where exactly you want the connectivity to actually land and terminate to make sure that you give the application the right performance. So just a few closing thoughts kind of. If you think about just what we talked about from the beginning here, networking doesn't just stop at the edge. It's very easy to just kind of just be like, hey, what am I building connectivity to? And just stop the discussion there. You really want to be part of that discussion and understand what the application is actually doing. Understand the concepts like VPCs and VNets, understand what the ingress and egress is for that application, and maybe that application or traffic from that VPC is actually going to hairpin and go back through the data center to get internet access. That may make sense for you, but then also at the same time, if you've got internet access literally a click away, maybe it makes sense to use the direct access from the CSP. So you've got a lot of different options there, and that's why it's important to be part of those conversations, because if you're not part of that conversations, decisions are going to be made, and you won't necessarily have control over things that when stuff goes wrong, they're going to call you and ask, why did it go wrong? One of the great examples I can think of is going back to the vMotion days. I had a customer I was working with, and they were like, oh, no, we don't do vMotion. And the server team was like, yeah, we do it all the time. And they're like, well, how are you doing that? We didn't give you any L2 stretch between those two segments. And they're like, oh, well, like VMware just enabled it. We just started doing it and it worked fine. Come to find out, they're just using the STT encryption within VMware to basically stitch together the two fabrics, and the network team didn't even know what was going on. So be part of those conversations. That way you can also be part of the solution as well. Do your research. Don't just listen to what I tell you today. Go out, do some training. There's lots of free resources or very reasonable resources out there on the public cloud networking. So do your own research and really dig into what's actually going on. It's a constantly changing space. The other thing I'll tell you too is work with your cloud team. They obviously know the cloud pretty well, but then also work with your CSP account team. They're there to help you. They're going to know what's coming down. So from like a roadmap perspective, they're going to be able to tell you what's actually coming and really help you make the best possible decision. Then the last thing, don't build a dock. We want to be part of that team. and really be part of those decisions, so that way we can give our users the best possible experience. That's it. There's a little bit of time here, so if we got any questions, take any questions. Otherwise, thank you.
I have a question for you.
Sure.
How do you see the cloud networking components that you're discussing here influenced by like Azure, Azure Stack, the AWS Outpost, where you have like the extension regions that are in your physical data center and the interconnection constructs of all that? I mean, not necessarily getting into the underlay because it's probably just internet or whatever, but like any insight into how those kind of come together from your perspective and your experience?
Yeah, I mean, as network engineers, it kind of all falls on us to make it happen. So it's hard to really say what exactly the different options are going to be, but it's going to fall under our purview essentially. And so instead of, one thing that I've seen is people would just be like, yeah, they're going to do Azure Stack and that's their thing. I'll give them a port off the network. Like, don't let that be the end of the discussion. Learn more about what's actually going on, so that way you can actually help them. Make sure that you're not just giving them a port off the network, and then when something goes wrong, you're just like, not my problem. So that would be my biggest suggestion, is get a better understanding of what exactly, and be open about why they're going down the Azure Stack path, why they're bringing in this switch into your environment. Be more open about it, and then hopefully you'll have a better understanding of the application. Any other questions? All right, thank you very much.